So as per request, I uploaded by the video I uploaded a few minutes ago. I will today we will tell today I will tell you the differences between old papers, okay, and what has changed in the new syllabus for the 2025, 2026 and 2027 syllabus. Okay, now remember, this syllabus will still be still going and still will be going until the last paper of the syllabus in 2027 October November. Okay, and then after that it will be the new 2028 syllabus. But if you see, that's actually the same damn syllabus, so it will be until 2030 that I have to update my notes with new content, besides the fact that I need to fix the errors also. Now, what has changed? What has happened since 2024 and 2022? Prisms, guidance, etc. blah blah blah. But what has become since 2022, which was a previous syllabus, and then the papers before that? Okay, this is for papers. Okay, this is in the you won't see the new changes in the new syllabus from 2024 and before. Okay, it is strictly after 2025 that the new content is in the papers. Okay, what has been added? Exponential growth and decay and surds. Now, I haven't made a video on exponential growth and decay, but I have covered it in my notes. Why? Because I am currently not looking at paper 2 right now, unfortunately. But exponential growth and decay is part of paper 2. It has been in igcse papers for longer. Okay, and surds has been introduced right now as well. It has been a part of the International Mathematics 0607 papers. Okay, and as you can see in a neglected file that I made, okay, the surds, there are a few questions I took from 0580, but the majority came from 0607. I looked at every single paper that it could have, and that is how we got here. And for 2024, as I said, had it in 2025, and that's why we see this file today. There's also repeated decimals. Okay, I do not know if it has been tested. Yeah, see, recurring decimals have been added. So we got reciprocals. Okay, you will be asked to name the reciprocal of a integer or a fraction. Recurring decimals, you got to convert a recurring decimal, which are given in a format what I have told in the notes, to a fraction. Next, what do you need to do? Expanding algebraic expressions with products of more than 2 brackets. Okay, meaning, what does this mean? It means if you go to 2.2, what does this mean? Includes products of more than 2 brackets. See, we have these 3 linear terms. Okay, I do not have my mouse with me, sorry. So you can see these are 3 linear terms. Okay, that you will be asked to expand or graph or anything, or do anything with them. Okay, expansion is the most simplest. It's like very less, factorizing expressions in the form ax cubed plus bx squared plus cx. Okay, now with this you do not have to be scared that, hey, it's a cubic, what are we gonna do about it? No, do not worry about being a cubic. Why? You can just factorize out a x. Everyone has an x in them. Okay, so ax cubed can be simplified to ax squared times x, bx squared can be simplified to bx x, and cx can be the cx. Group all the x's, we get ax cubed plus bx plus c, ax squared plus bx plus c, and that is a quadratic. You guys know how to factorize quadratics since the beginning of the syllabus, and so you do not have to worry about it. Conventions for representing inequalities are number line and graphically. Now, conventions, what does it mean? Conventions graphically and I don't know. Here you guys know how to show a number line inequalities. Okay, it's by dot and circle thingy. And this convention, broken lines should be used to represent strict inequalities. What does this mean? This broken lines or dashed lines or dotted lines, as we like to say it, these will represent strictly and only lines which are in a inequality, okay, a proper inequality. Solid lines should be used to represent inclusive inequalities, meaning inequalities with an equal sign. Okay, so here it is a solid line, so it will represent solids. Now why does it highlight this? Well, I guess they just wanted to, but my theory is they did it without specifying that, hey, we will have this notation. But it's great that they are telling us what will they tell us. Shading should be used to represent unwanted regions. Okay, meaning the region that we do not want. Okay, this is usual, but unless the question tells us that, hey, I want the region instead of I don't want the region, then sure. Okay, but this line means the shaded region, the shaded area, the shaded part of the graph will be what it is not wanted. Okay, and I'll tell me the inequalities of the unshaded region, of the white region. Okay, so that's that. Unless the question tells us, example, the question tells us, hey, I want the gray part, give me the expressions which make up the gray part, and so you will write the expressions using the gray part. If you haven't done coordinate geometry, this chapter might be a little difficult, but you may do this. You may do coordinate geometry before doing inequalities. Okay, list inequalities that define a given region. Yes, this is what I was saying. Yeah, tell me the inequalities which define this region. Linear programming is not included. I do not even know what on earth linear programming is. Oh, yeah. Okay. If you do not know, linear programming is when you set up an inequality to represent a count. Okay, example. A example is that we have a bus which accommodates at maximum 15 people, and there are how many people that we need? There are at least, let's say, 297 people. Now we want to set up an inequality to tell us how many buses, what is the least amount of buses do we need as an integer to accommodate all of those 297 people. So the answer would be what? X is greater than 297. X is greater than 19.8, meaning it will be X should be more than 20 buses at least. Okay, 20 buses, and so on. Okay, but this is linear programming, okay, which I told you this will not be tested in the syllabus from now on. Okay, I think there was one where it set it up a equality instead. Okay, but these are not in the syllabus right now. I will try to make my topicals such that they do not include linear programming, but it's like, okay, since I myself do not know what it even is, what does programming even mean linearly, so I hope I can make another video on it, okay, soon, later. Interpreting the gradients of curves 2.9. Okay, so if you go to curves 2.9, so graphical and graphs in practical situations, we will now interpret these. I have covered graphs in practical situations. I think they just wanted to highlight this a little bit so that we can do these properly and remind us that we need to do these types of questions again. Next, graphs of functions in the form ax to the n now include values of negative a half and a half. Okay, normally it was integers, but now we have square roots and inverse and like reciprocal of square roots of x. Okay, so it will be either a square root of x or a over the square root of x, or a to the negative a half or a to the half, and by using indices rules. Okay. Continued. Graphs of functions in a form now include a constant c, i.e. a b to the x plus c. This means not before we had graphs which exponential graphs which had the horizontal asymptote at only 0, but now since they tell us that we need to expect a constant being added to it, the horizontal asymptote can be different, it being the value c. Given a is 1, a, and if a varies and c varies, then the horizontal asymptote may change. Next is interpreting graphs representing exponential growth and decay problems. I don't know about this. I never drew we never have seen a question like this before. But as I told you in the syllabus, that in my notes, hopefully, that when the form ab to the x has x be negative instead, ab to the negative x, it will represent exponential decay. Okay, continuing. I just tasted something sweet. Okay. Recognizing, sketching, interpreting graphs of specified functions, including knowledge of turning points, asymptotes, and symmetry, where applicable. Now, this is about drawing curves. I have made a video about it. Okay, and I think you guys know what turning points and asymptotes are. Please, I do not want to repeat it again. If you guys do not know what they are, please check out my previous videos. Domain and range composite functions. These are simple. Frustum, hemisphere, radii, semicircle, major and minor. Yeah, you guys can see in the new 2025 papers, we get a piece of thingy called a frustum. What on it is a frustum? Okay, a frustum is a cone or a pyramid which you cut in half. Okay, you cut by like in its path. Okay, like take a large pyramid and take a party hat and you cut it from the middle of the height. The shape that you get, like a slanted ring type of thingy, that is a frustum. Hemisphere, you guys know. Radii is the plural of radius. Okay. Semicircle, half a circle. Major and minor. Now, major means big. By major, okay, and minor means small, as you guys know by the word minority. Minors. Major and minor, these Okay, the only times we use these words is when we are talking about the angles. Okay, major and minor would be a word you might hear in other things used as major impact, minor impact, etc. etc. And here, let's talk about the magnitude. Also, the magnitude of the angle. Major angle, minor angle. Major sector, minor sector. Major angle, major arc, minor arc. Alternate segment theorem. This is lovely. I cannot find any questions testing this. Okay, but this is a rule you guys have to know. Alternate segment theorem. If you guys not know, then you guys are cooked in the later examinations. Okay, this is a rule. It's because you guys saw I was struggling in explaining it in my previous circle theorem videos until the last circle theorem video, the one after the topical solving, where I finally understood what this term meant and explained it to you guys. Okay, and in my current version of my notes, I have revamped the circle theorems chapter and explained them properly. Okay, so you guys may check it out. How do we test alternate segment theorem? Calculating the angle between a line and a plane. This is also a very good interesting thingy. It's basically using Pythagoras twice. Pythagoras twice. By getting a Pythagoras to get the diagonal. Okay, the diagonal that the line's shadow casts on the plane, and using Pythagoras again to find the length of the line or the angle between the line and the plane, etc. 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 Learning outcomes have been from existing topics remove. So I don't know what this is. Learning outcomes. Wordings have been removed. Okay, let me tell you something. Learning outcomes really is like we skip it, but let's see. Proper subsets, it's removed. Okay, now proper subsets and subsets normally. Okay, those are different. Okay, but right now, okay, in today's syllabus, they are the same thing. Okay, we will only have this like the C and the equal sign under it, the C dash thingy, to represent proper subsets. What are proper subsets? They are subset. Let's say A and B are proper subsets. What does that mean? A should have and has some elements of B, but it can never have all the elements of B. Okay, we will do this later when we get to the sets chapter in detail and properly. Okay, when I make a separate video on it. Increasing and decreasing a quantity by a given ratio. This is still tested. I think I still have kept doing this. Okay, I do not know, but you guys should know how to do this. Okay, I do not know if this is removed from the syllabus, if this even means it's removed from the syllabus, but I think these will still be tested. It's just that it's weird. Use of maps to notation. No, I think these are removed. Yeah, these are removed. So increasing, decreasing a quantity by a given ratio, that's removed. I have never seen it passed, in like newer papers as of now. So I think it's removed also. Reading dials, I've never read a dial before after one dreadful. There's like only one dial question I've put in my notes, and after that, I've never read a dial before. And I will, obviously, in physics, but come on. Okay, and increasing and decreasing a quantity by a given ratio. No, you skip this. Use of map notation. This notation is removed. Okay, I hate this notation. I put this in my notes, but I still hate this notation still. Constructing simple geometric shapes that cannot be formed only from triangles. What? I don't know about this. I think it's like using triangles to make shapes. Yeah, I don't know about this. Constructing and yeah, see, so example like a circle or something, triangle, a square, etc., etc. Those are removed. Okay, so you won't be drawing different shapes. Okay, specifically, so you won't be tested for drawing rectangles, squares, trapeziums, etc., etc., etc. Parallelograms, considering perpendicular bisectors, these are removed from the syllabus. Okay, so old videos that talk about it, or you should watch them carefully. Remember, the video on my channel, they only have questions tested from the new papers. Okay, I have tried my best to remove questions that do not test this behavior. And constructing angle bisectors, these are completely not in syllabus, these are in local. Showing that two triangles are congruent, this is also removed. The hat rotation of angles has been removed. This is a good thing because it then makes you smarter. Okay, because it's like reading a Quran without the mushaf coloring. And the more you try to detect it yourself, the more experience you get, the more better you get. So hat notation, it is difficult to type in latex. Okay, difficult to typeset, but so that's that, I guess. That's why it's a good use of removing notation. I guess we have covered everything except the above mentioned remove. Let me read this remaining section. Teaching time has not been changed. It is, and was. Wait. So you can see, total it becomes 130 hours. Okay, but from the 130, 6 hours are gone. From 6 hours are removed because those are used for practice, for exam preparation. So in total, a teacher, we can spend 124 hours teaching you, and in the remaining 6 hours you will do past papers, which it's like three papers you would be doing. What? No, I guess it's like 130 hours to teach you questions, that you teach you the syllabus, and the remaining is whatever you want. Okay, 130 hours is like a few how many days? It's like 5 days of syllabus. Okay, so I can teach you the syllabus in like 5 days or something, but come on, who has time to sit in a room and watch me yap for 130 hours non-stop without any breaks, without sleeping or something? Obviously this would be like extended to like a few weeks or something. Okay, with timed breathing sessions and something. If we do this, you can expect me to come. If we do example 130 hours, but realistic, that would be like 3 hours a day, that would become 43 days. No thank you. 130 hours divided by if we do it in like a month, 30, so it would be like 4 hours a day, 4 hours every day, which I think is more exhausting also. Or doing an accelerated, skipping the bloat and actually studying. Okay, I think we would end up with enough time. Math notation is with the subject content. Ring outcomes have been numbered, listed by bullet points. Short. It is just a formula and conventions. It's a command words, wording of the learner, wording of the aims, wording of the AOs. Okay, blah blah blah. Rebalance to improve accessibility and better candidate experience. Wow. So, board examinations will include a list of formulas on page 2. Remember, on the second page, you will 100% have a formula sheet. You can see this in gcse, gcse7, International Mathematics. Every single paper I saw had a formula page on its paper 2. On its page 2, sorry. Having upgraded qualifications. Oh, paper 100, mixture of structured and unstructured questions has not changed. Paper 2, it became 2 hours, and structured and unstructured, and still 100. Okay, good. Now I wanted to tell you about this earlier thingy, Loki and matrices. These have been removed from the syllabus. Loki required you and tested you to do bisectors, bisect an angle and bisect a line, draw the Loki between 2 points, between a line, a point, and between 2 lines, etc. Blah blah blah. Areas, shading, this stuff. And matrices is a different kind of worms. That's why I removed some questions. Here you can see on the questions I removed. Okay, 70 marks from matrices and 53 marks from Loki. Okay, that's how many marks we got, and 72 marks and 23 marks from decimals and thirds. Now I'm not including all of the marks from repeating decimals and thirds. Okay, I will be trying to fix more parts of the tropicals. Example like what do you call it? Wait. Yeah, trigonometry and mensuration. Those two, unfortunately and oddly, have like very little questions. Okay, little as in little for me. Okay, it does not help you practice properly. So I will be looking at questions and adding questions only from igcse. Okay, and I think that would be enough for my sanity and not have to make another, like, import so many questions. Okay, I God forbid how difficult of questions 06, 07 could have. Okay, because it's a different syllabus, but 0580 is the most similar subject to 4024. Okay, 06, 07 is like a different demon. Okay, it is a similar demon, but it's like a similar different demon than this O levels and igcse maths. Okay, so I hope you guys like this video, learn something. If you are a teacher or a student, these may help you out. Learn and judge what questions you should be doing, what questions you should be missing out, and what questions you should not. You should try to avoid. Yeah, you guys can test yourself on the removed topics, but they will be useless. Okay, for topics which I am sure are removed. Okay, and you guys no longer see them being tested in the syllabus. Okay, so yeah, bye for now.